For a function to be considered continuous at some point A, the following conditions must be satisfied. So first off, before we get going into this, let's talk about what continuous means. So continuous really just means that you could draw the function without taking your pen off the page, right? Like that would be a continuous function, but something like this and then ends and then starts up here again, that's not considered continuous, right? You had to take your pen off the page. Okay, so in order for it to be considered continuous, we'd say f of a is defined. Okay, so what does that mean? Well, it means that f of a is some point actually on the graph, right? So if you have some function where f of a doesn't exist, then it's not continuous. Okay. The limit as x approaches a of f of x exists. So we learned in the last part that the limit exists if the limit from the left side is equal to the limit from the right side. Okay, and then the other one that has to be true is that the limit as x approaches a, so that value, has to be equal to f of a. So in that case, we just can't have it be the case where it looks like it's approaching some number from the left and from the right, let's say, but it turns out there's a hole there and the point's actually down here, right? Something like that would be the case where it wouldn't be continuous, right? All right, so let's look at example 2. So state whether the function is continuous or discontinuous of the following numbers and explain. Okay, so at x is equal to -1 on this graph. So when x is equal to -1, so we're looking at this section here. The function is, and we're going to select whether it's continuous or or not continuous. Okay, so in this case, we would say that well, you can probably see right away that this thing isn't continuous, right? You definitely took your pen off the page, right? So it's definitely discontinuous, but the question is why? Okay, well, in this case, if we look at it, the limit from the left side, right? So the limit from the left side of this function is in fact it's not equal to the limit to the right side. So this would be the case, right? That's why it's discontinuous. Okay, and that was really just because of this part. All right, so looking at the next one, so when x is equal to 3, okay, so when x is equal to 3, let's check it out. So we've got, well, let's try the three of them, right? Is f of a defined? Yes, it is, right? F of a is at 6, right? So f of 3 is at, -6. Is the limit from the left side equal to the limit from the right side? Yes, it is. It's at 6. And are they both the same number? Is the limit as x approaches 3 the same as f of 3? Yes, it is. So we'd say that this is continuous. So in this case, it would be all of the above. Okay, and when x is equal to 6, okay, when x is equal to 6, so in this case, f of a is defined, right? F of 6 is 1. The limit from the left is approaching 6. Limit from the right is approaching, the limit from the left is approaching 7. The limit from the right is approaching 7. But the limit as it approaches 6 is not the same as f of 6, right? They're different. So it does not meet our last example there, our last point there. So we'd say it's discontinuous. So it's discontinuous because they do not equal each other.